Hello there. Hello? Hello there. Hello there. Alright, just say something in the chat so I know it's working and you can hear me. Alright, that's probably good. Hello? All right. I think parts is here. Let's see. The chat should be on. I think I enabled chat. 1 second. Edit. Hold up. Stand by. Restrictions. What are we doing? That's it. Playlists. All right, I'm just going live chat. Yeah, the chat should be good. 10 seconds. No. All right. Oh, looks like people are in the chat. All right, sounds good. It just might be on your part. The chat. If you're on mobile, it might be different. All right. Looks like we have 3 people watching. That's including that one. All right, so we're just gonna get started. I'm going to show you what I've been working on the past few days. A big accomplishment was here. Let me just put my rocket body to the side. Was the TVC thrust vector control that I somewhat finished. I kind of took some gardening wire and used that for the TVC servos because the proper wire hasn't come yet. I need to order that. So that's pretty much it here. I don't know if you can see it. Here's the servos. Some controls the X and then this one's the Y. Sorry, this is the X and this one's the Y. Yeah, it's pretty neat. That's what I've been working on lately. All my parts have come. I'm waiting on the PCB board that's going to arrive Tuesday, I believe. And then the other parts, and I should start soldering that with my teacher that's helping me with this. Yeah, I think that's pretty much it so far. Today it's going to be pretty loose, but I'm going to be attempting to assemble the ejection part that shoots out the parachute to land this craft safely back on the ground. So that's gonna be primarily just on the top half of it, and we'll be using this too. So we're gonna put this to the side. Yeah. All right, so I'm just gonna get started on that. Any questions, just drop them in the chat if you can see it. And yeah. So I'm just gonna start up on that. gonna pull up the instructions just so I know I'm doing this step by step correctly and not messing it up. Because last time I did this a few days ago, let's just say don't use epoxy for things that are going in the rocket. It never turns out okay because it takes like 9 hours to dry, which is you have to sit there and like holding it together. So this part that's made to slip through has to stay on. So this part, once I cut this, and then that'll be later down the line. But this just don't use epoxy when dealing with the piston ejection system because it's a pain when you have to start over. I already wasted like one frame one of these. Luckily, I have like 10,000, so it's pretty good. But yeah, it's pretty much my advice to epoxy when you're using epoxy. All right, so first I'm going to attach this 3D printed piece that holds the what is it called, the shock cord that is attached to this eye bolt here, or not eye bolt, little thing here, which will let's see if you can see me correctly, which will hold the parachute and be connected to the nose cone, which I also 3D printed, but I left that at my house. Oh, yeah, fun fact, I'm at my grandmother's right now. So this is why next live stream or videos will be a little different setup. So FYI. Anyway, yeah, so this piece I would have 3D printed a U-bolt, but this piece has to be metal because it takes the most force on the rocket when it's descending. So this has to be metal, which I have here and I have attached. I'm going to start by gluing these parts together. Pretty straightforward. Yeah. Okay. Looks like we got a new subscriber. Charles Raggio. I wonder who that is. It's the same last name as me. That's funny. All right. So we're gonna start with that. I gotta find some sandpaper. Here's all my pieces for my rocket. I can go through those later. I'll have to show you pieces. That's not good. Alright, that's good. Alright, so gotta make sure this is really tight because you do not want this coming loose because it will ruin your day and your rocket. Alright. Alright. So what I'm just using normal super glue. Epoxy you don't really need, you just need a medium super glue, I think. Medium, yeah. So you don't need anything big for this part. need a little more. Oh, it should do. Oh, this stuff smells. Hurts your eyes. I can use one of the masks, 10,000 masks we have, byproduct of Corona. Alright. Alright, so what I'm doing right now, for you that just joined, I don't think anyone joined, but if you're unclear, I am, got some on my hand, that's not good. I am just glued the U-bolt piece that connects the shock cord to the nose cone and the parachute, and then the piston that sits in the middle, which I'll be constructing today too. This part is primarily just to kick the nose cone off so we can deploy the parachute at apogee. That will go the PCB board and FCC flight control computer will be programmed to tell the pyro channels, which fit right in here, to fire at 25 meters below apogee. So that's probably a second after apogee. They will fire the pyro to the nose cone, deploys, and the parachute hopefully comes out and it's a nominal descend. If that doesn't happen, another case scenario would be it has tipped over 45 degrees and the rocket's telling it to abort, which will once again fire the pyro and release the parachute. Hopefully, in most cases, it doesn't do anything. It just flops and hits the ground. But hopefully, it'll save the flight and not cause a lot of damage to the rocket or anyone around the rocket. So that's that's the reason that we make a piston injection system. And a lot of credit to BPS Space and Joe Barnard, who provided these files, 3D printing files for these two pieces, and who I took inspiration and what is it called? Who helped kind of my curiosity for a thrust vector controlled rocket. That's what I'm making right now. I have a different rocket with Team Aerial called the Aerial 1. You've probably seen in past videos us constructing the landing pad and that rocket. So yeah. So here it is. Here's the piece if you want to see. This is a thrust vector controlled rocket, which I'm creating right now. Yeah. Anyway, here, someone's texting me, giving me advice. Let's see. Okay. Is that better? Let's see. Is that better? Let's see. All right. That's better, right? Is chat working? Is chat working? Can someone type something in chat for me? I just want to know. I'm just not talking to a void. Nobody. All right. I'm going to continue while someone's typing in chat. All right. So I think this is dry. That's another thing with epoxy. It takes 9 hours to dry or something like that. It's like 5 minutes, but it feels like 9 hours. So that's good. This seems like a tight fit. It's not going anywhere. I mean, I could always put some super glue down there. It's not rocket science way, but I mean, if you're not sending something to space, it doesn't need to be airtight. I mean, soon we might send something to space. Wink, wink. Anyway. No. Bye. All right, so what we're gonna do, we're gonna need to get. I'm gonna look through settings right now. Stay with me. I'm gonna try to fix the chat. It looks like someone in chat said, it looks like it's working. Is anyone on computer? Could they try to type in chat? If that works. I'm gonna look through this. Like the rocket, there's gonna be a lot of problems. I can tell you, the rocket may not get off the launch pad the first time, so. Allow comments. News. I'm just gonna keep going. Some wise people are telling me to keep going. All right, so our next task is going to be so this is the tricky part. This is probably, besides the computer and TVC and just putting the rocket together, this is probably the hardest part, I'd say. Because we have to cut a perfect cut down this this piece, and then we have to fit it to, this is perfect, specifically the 3D printed piece is smaller than a 74 millimeters airframe, so we have to bend it to this coupler so it can slide through, so this can slide through freely in the airframe, because these pieces are designed to connect two airframes to each other. So they're just a little bit smaller than the 74 millimeter airframe here. So we have to make that way smaller so it perfectly slides through the rocket. Like, see, there's some friction here. We don't want that because the pyros aren't, the firework pyros, they're not made to blast something out of a tube. So we have to make it so it's really freely moving so it can pop out and hit the top of the nose cone. Yeah, that's what we're gonna do now. I'm gonna get a piece for my rocket. I'm gonna get a X-Acto knife. I wonder where the knife is. Okay, got it. Alright, I think I got a knife. A very sharp Leatherman knife. Any hobby knife will work for this. Preferably an X-Acto because it's extremely sharp and it glides really freely through this cardboard airframe. But this should work. Just gonna check one more time. Oh, look at that. Looks like I have an X-Acto here. Not the sharpest blade. Get a different blade here. Alright, that looks good. Alright, no one has joined yet. So we're gonna have to cut this piece. Also, next time I'm gonna have these couplers that help they sit and they hold the rocket tube. I was printing that, but then the print failed because of me using the wrong filament for the wrong type of print. Kind of a Fox moment, um, but yeah. So we'll have that next stream to make it a little easier. I also, while I'm doing this, I just downloaded Kerbal Space Program today, and I successfully landed without blowing up any Kerbal people 2 rockets, which is pretty cool. I used a Gemini capsule, which is why not. I think we just came out up on like the 60th year of first American man in space. That's pretty cool. So that's what I'm doing right now, very slowly. Bad experience with cut my finger last time I did this, so don't want to mess it up and mess my finger up. I think the problem last time was just the dull X-Acto knife. It seems pretty sharp. Alright, I would just go right through it, but I'm really nervous. I don't want to mess it up at all. Like, I hate ordering stuff and then waiting for other stuff to come and like run. It takes forever. There we go. Alright, that seems like a really nice. Don't cut your towards yourself. Seems like a nice cut. That's perfect. That's a really nice cut. Baby steps. Celebrating over the tiniest cut. Anyway, we got that. I'm gonna do the tricky part and try to match this up and not let it die. Anyway, so I think my satellite. Yes, I have a satellite. It's a I'll put it in chat if you guys can access it. But it's an Ambisat. It's a carbon emission sensor, which is really, really interesting. It detects MOX and forget the other one. Anyway, MOX or MOX is a greenhouse gases, so like your car emissions or factory. So my satellite has a sensor built in that will sense that and send data back to my computer. So I should be getting that in the mail soon, and then I'll code it and ship it off to Ambisat again, and then they'll put it on the iOS's Neptune rocket, or they might crossing my fingers, they might put it on a SpaceX or SpaceX Falcon 9. So that would be really cool. They rarely ever do that. They do that for the big CubeSats, but yeah, it's gonna be a really cool achievement to have a satellite of my own. All right, so now that we like have it cut and we have this, I'm gonna get my shock cord, which is over here. All right, so this is my shock cord. I got it off of Amazon. It's pretty much just a bungee cord, but rocket branded in front of it. So it should be like 2 lengths of one of your body frame. So like just take this for example. It should be 2 of these. It's just normal. I think it's like 3 meters or something. So like 9 feet, or I don't know how meters work. So it should be like that. So that's 3 times over. That should be good. So that's how long you want your shop core to be. It's not like I don't think any of you are gonna build a thrust vector controlled rocket anytime soon. But I'll just walk you through it like you're doing it. Alright, so this should move freely because there should be like no resistance. Close to none. Alright. Oh, that happened. Like looking at the manual and trying to multitask here. Very hard. My suffering. Alright. Sorry for the chat, guys. I don't know if that's just mobile or me, but I'll try to fix that next live stream. We'll probably do like 2 live streams a week or something. An update live stream or something. All right. Alright, so we're gonna put this to the side, the bungee cord, or shop cord, I should say. And we're gonna glue this part. I'm gonna need that. Alright. Took a village last time to glue this. Needed like my brother's help for this part, but I think since the cut's really nice and I feel good today, and I'm not using epoxy, I have like this weird relationship with epoxy now. I kind of hate it. It's like that. Yeah, I'll show you later. It's like weird. It doesn't come out till it does, and then it just squirts everywhere. All right. Let's get this underway. I'm not using it. All right. This is the tricky part. You have to match each part. I mean, like, it's not NASA doing this, so they don't have like this high tech things. So I guess just eyeballing it because it just needs to be a little thinner than the ear frame. All right, here we go. That's good. All right. Okay. Did everything. Looks good. Slowly moving down. It's like that's not good. All right, I'm gonna have to now maneuver and get that. BRB. There's like this hole down here where like man's land because it doesn't come back. All right. Let's try again. Luckily the glue didn't set. This is why you print with PLA because it doesn't break. All right. No, I got that on my hand. This is so nerve-wracking. Doing a live stream in front of people and doing rockets. I'm good at one of them. Try to guess. Oh, my fingers want to glue to the. No. This looks much better than what it was the other day because the other day it was just everywhere. It was like on my fingers, it was on my arm. It hurt. Epoxy, no. So this is an upgrade. This is like looks much better. It's gluing like instantly. Super happy about that. I'll have to wash my hands. Got a little bit on my hand. It's okay though. If you watched, I don't think anybody cares to watch our videos, but I think it was our rocket building episode. where we I think I like got epoxy all up my arm because Henry, one of our other members, this short little blonde kid, yeah, him, he I think he bumped me and got it on my arm, or I was just being clumsy. Like, we had to do like this movement because it's so difficult. Like, definitely not made for a bunch of 14 to 13-year-olds, but we did it, so doesn't really matter. um all right. Hope this is interesting and not just droning noise. See, on my Leatherman, it has like this thing where it's this safety. This is not mine, and it seems very dangerous. I'm going to do that later. I'm not in a hurry. All right. So next step is going to be, well, waiting for this to dry, but mainly just knocking this thing out. I think we should wait, just to keep it safe, play it safe, till it molds over. And then what we're going to do, we're going to knock it out of the airframe so we can thread the shock cord through it and start attaching the pieces. Maybe next live stream or so, like, we can do like drill and cut guides and assemble the nose cone to it. But I don't think I can do that tonight. So yeah, I'm just gonna clean this shock cord. Maybe in a future live stream, I could do it kind of an update, like do everything, like show a PCB board, which should be here. Thanks to Delta Space, I grabbed their PCB board file, and I kind of took it, and now I'm using it. I'm just gonna use it for my starter, and hopefully, like, if I get a little better at everything, flight computer wise, design my own an Eagle, and yeah, I don't know. It's all time. Alright, so it should theoretically slide through perfectly if each wall is, I don't know, like they're the same on each side, because look, you have to glue them together again. Like, this one's a little bigger than that one on this side. So that's going to change the diameter inside, so like it's kind of stuck here. So that's going to be fun getting at. Try not to break the PLA. 3D printers are so unpredictable, or at least mine is. It's like so hard. All right, I'm just gonna go out the other way because this part doesn't need to slide through, which is good. It's this entire tube that slides through, so this part's just to connect the shock cord. Oh, I think John Taylor Parts is in here. We call him Parts. Is in this live stream. He big thanks to him for helping me with the primarily the computer, flight computer, and helping me kind of mentoring me through that process. So big thanks to you. Couldn't have gotten to this stage without you. So yeah. There it is. Gravity. We love it, and sometimes we hate it. All right. So I think the next step looks like that's gluing. I'm gonna look over the the next step here. Check chat. Looks like nothing's there. It's running on me. Oh, I did a cleaner job than Joe did. Wow. Pat myself on the back. He's precision too, so. Oh yeah, and little totally rocket science. The other day, so I purposely, knowing that I could drill a hole through this, because when it printed a like much smaller hole, so this shock cord wouldn't fit through it. So what I did purposely, knowing that I didn't want to at 10 o'clock at night go searching for the exact bungee what is it called, shock cord he uses. So I knew that I had the type of drill bit that I could just drill right through this PLA. It's like super soft, and just get this shock cord through. So yeah, it's kind of definitely rocket science, but it was a good part on my end. I don't know why I'm telling the story, but yeah. So if it looks dirty, that's because I took a drill bit and drilled through that. All right, so it should be dry by now. Which way do we want pointing out? Do we want to go this way? Yeah, that way. Oh, super glue on your hand hurts. All right, so I want that to go out because it's gonna sit right here. We want it to go that way. With the clean side facing out. Show that you're a professional. On the inside, you're not. So, I mean, it's not like any of this matters. It's gonna blow up the first time anyway. So. Right. I have the KSP Kerbal Space Program theme song stuck in my head. It's like it's like a Wii Sports / Mario 8-bit music. I don't know. Pretty good. And then I changed to swing, and then there's jazz. It's pretty interesting. Definitely nerds that made that game. All right. Now that we have the shock cord through, I think I'm going to, let's see. All right, we still have 4 people watching. I think I'm gonna glue that now. All right, I don't know. This looks like not enough shock cord, and mass doesn't really matter with this type of rocket because I'm gonna be using an F-15 rocket motor, which is like long burning, huge motor. It's like this big. Anyway, I don't think it really matters at this point. Thrust vector control should make up for a little bit of that, even though that's displacement. So I don't know. I don't know if you guys can type in chat, but should I make a longer shock cord because it's kind of getting short, or should I mean, like, I have like 10, 20 feet of this stuff, so I mean, I could make a little more, make it bigger, safer. I don't know. Text me, or people that have my text me. All right. don't think it needs to be any longer than allowing the parachute out. I agree. I agree. Because here, we can do a little eyeballing here. This sits in here. This is all of this is gonna sit in here. The parachute probably sit here. Nose cone, I didn't bring that, but the nose cone's a black nose cone. I can show you later, but in a future stream. But it doesn't stick out very far, and there's no payload section, since there's like, not that we need it, but if we were like not doing a flight computer, we could like put a altimeter in there, but there's no space for that. So I think you're right. I think we don't need any, because like it's gonna probably pop out to there, right? A little farther. I'll release the parachute. Yeah, it's good. I'll do that. Something to show you. Don't forget. I'll write it down. Later. I'm gonna include that. Right, we're gonna glue. Alright, if I mess up, don't blame me. Blame Joe Barnard. It's his fault. I'm gonna have to get this out pretty well secured. That's pretty good. Super glue won't have to do a lot then. I'm gonna make a contraption really quickly. I'm gonna see if I can remember how to tie that knot. I'll do that later. Looks like that's dried. I'm really thirsty. Get a glass of water in a minute. All right. We have created a contraption to pull this out when needed. Wow, amazing. Thread the needle again, and now we're gonna glue. All right. All right, here we go. Go down there. I feel like next live stream there should be like some music because it feels so dull. You normally in conversations like you hear people like talking or like it's or a presentation or the OG live stream, but I don't like it. It's like I don't hear humans. I can't make that connection of feedback or something. So I'll probably have to play like some music next live streamer right now. I don't know. Give me some suggestions. All right. Now I love this super glue. The epoxy took. I don't know. It says it like here. Let me get this. All right. So it's a Gorilla Glue epoxy. It sets in 5 minutes. Clear. It sets in 5 minutes, but in the real world, it sets in like 30 minutes. I'm not joking. I sat there holding it together for 30 minutes, like, and it kept coming apart. Like indoor and outdoor, water resistant, but is it rocket resistant? Like, come on, people, you gotta think of these things. All right. I think that's good. I can see myself playing back. It's creepy. All right, so we're nearing the end of the injection building. I'm sure we could talk about other things for like 5 minutes. Oh, it's the not time part. This is gonna be very funny, guys. I can't tie knots. Like, so I tried it like a few times, and it looked like a rat's nest. It looked like me fishing on a swivel and rat's nest appearing in my. Anyway, yeah, inside joke. So this is gonna be fun. Let's watch, everyone. So I think I have to go like that, and then you have to like go over it, and then go through the hole. It's supposed to be 5 times, but like I'm not doing it 5 times. I think 2 times will get us somewhat. Will get us not safely, but it will get us to the ground. I didn't say safely, so don't when it blows up, don't look at me. Say safely. We'll know what to inspect when it blows up. All right, so we're gonna pull it, make sure there's some slack. Should be good. I mean, no human's gonna be able to break that. Maybe gravity, but yeah, look, that's kind of it. Looks like 2 of these times another 2, and then add 1. So 4 plus 1 is 5. So yeah, it should be good. That's funny. Super glue on my hands. Not a good feeling. I should have put gloves on. Ow. I mean, it doesn't hurt, but it's like me itching it. Like, no wonder they epoxy like 100 times worse. Even the name sounds toxic. I'm gonna send this to someone 1 second. Try to send it to other people. I don't know. My friend's awake, part of Team Ariel. I don't know if he's awake, but I think he can see it in the morning. Send it to my friend that's interested. All right. All right. So I think this is what I was going to show you. During the break. It's my parachute. This is just a nice parachute. Here, I think you can see. I'm going to tilt the camera up so you can see my face. All right. Excuse my hair. It's like, what time is it? I don't have my watch on. It's 10:40 at night, so don't shame my hair. So here's some parachute. Looks small. It's a 15-inch parachute. This will be the drogue chute of my rocket because I was kind of like in a rush, and I said, 1 parachute will be fine. It's 15 inches. And then when I got it, I was like, it's 15 inches. ... Only 15 inches. So I'll probably order some few cheap nylon parachutes, 2 others. So 3 parachutes should be fine. Looks like we dropped someone. Watch. Anyway, Don't know who that was, but thanks for watching. All right, so that's the parachute, fancy 15-inch parachute. All right, so this is my knot. I'm gonna have to do that on the other one. Let's just check the instructions. Thanks for watching, guys. It's really cool of you. My horrible stories. Stay with me. All right, so we're gonna do it on the other side now. I think that will be done for the piston, and then we can kind of test out. I'm gonna order some firework. What is it? Well, I call them pyrodes for rockets. They call them something else for fireworks. But pretty much, it's gonna sit right in these two again. It's gonna fire. It's gonna set in motion. No pun intended, because it's going very fast in motion. It's gonna set in motion this, which will shoot the nose cone out. So I'm gonna order a few of those, and then we can probably do like a live stream of testing the pyros. Once I get the computer finished, it shouldn't be too long. I would say a month to finish that thing, because I'm a newbie at that kind of soldering. Yeah. So I would say probably a month before we can get that a pyro test or any test in. So that's not good looking. Not oof. Eesh. Actually, no, it was just tangled. That's good. Testing. So yeah, definitely look forward to some team aerial testing. That'd be kind of cool. I don't know. Watch blow some things up and control blowing. So nothing arsonistic, or what's the what would you say? Nothing. I don't know. You know what I'm saying. All right, so as you can see here, oh, that's the wrong way. Anyway, I'll use an example. This is the, oh, I need to angle it down. That's not good. So this is, this will be attached to the rocket. I'm not going to glue it because that's not very, I'm going to screw it so I can remove the screws if I need to remove the flight computer or whatnot, or replace stuff. So this is going to be connected to the rocket. So this part will be connected to the rocket. This part will be connected to the nose cone. And then I can just get a parachute, for example. I'm not going to fold it or like get the knots correctly, but it's very complicated. Yeah, doing this. All right. So we're going to take our parachute and kind of just feed it through this, like whatnot. I don't have the nose cone on me. I mean, I have the other nose cone that doesn't fit on me. It's huge, like bigger than as long as my head. So I think I can show you that. But anyway, so like the parachute's attached, and we're gonna have to do it the other way. 1 second. Stay with me. We just came up on an hour. Thanks for watching, guys. Make sure to like and subscribe. Sound like a YouTuber, entrepreneur, or someone. Anyway, so that comes off. We're gonna have to do it the other way, the shiny bit on the U-bolt, because we want the piston part to be facing out, so it can knock the stuff out. Out. It's a Canadian would say. All right. There we go. This project has been underway for about a month now. Oh, hi Finn, Mothra, what's up? Glad you could join. We're just building some piston ejection pieces right now for my rocket. I'm glad you could join us. So yeah, so this is kind of here. Let me get my other parachute. It's very, 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 very big. Yeah, that's like here. Let's say, look at this. It's it's here. Let me. It's almost as big as my airframe for half of the rocket. Like that's way too big. Um. Also, it fits, but it takes like 9 hours to put in because like it's that well. I wouldn't say it's well made, but it's like I think it was a plastic mess up. I don't know. Anyway, so this my nose cone is probably about this big. Can you share your screen in this? I would. Anyway, so this would fit on the nose cone, not this big. It'd fit onto the rocket. Parachute would be folded up right next to it. The pyro would be in these two. So we've reached apogee, right? The rocket's decelerating. Oh, someone. Sorry, it's urgent. Oh, okay. Sounds good. So what's gonna happen is reaching apogee, the BMP 380, which I'll show you in a few minutes, will tell the flight computer, the TNC 3.6, to fire pyro. We'll just say 1, for example, and then it will fire pyro 1 at 25 meters below apogee. So apogee is the highest the rocket will go before losing momentum and thrust. So it'll fire the pyro here. So shoot out. Nose cone will go flying, still connected, and it'll shoot back. The parachute should go out, and it should hopefully catch the draft. That's why we have 3. So if one of them's messed up, we'll come down not slowly as we would with 3. With 1, it's gonna leave a mark in the grass for sure. You can probably look at BPS Space, his first few launches. I think it was I don't know what it's called. Sorry, BPS Space nerd should know this. Hold up. Video. Scout V. So I think he failed all the way up to 2017 or something. Like that's 2 years of work. He started in 2015. And so yeah, they all mess up. And anyway, yeah. Long story short, so this is how the ejection system is gonna work. It was a success. Last time it didn't go really well. Epoxy doesn't really work on this. It should be different. I should have known that, but that's trial and error. So I think we're done with the piston ejection system. Here, let me just put it. I think it's dry enough so it won't stick. Here, let's see. I'm gonna put it in the rocket body and show you what that looks like. It's gone. I'll put rocket parts are flying. It's okay. I'll see worse. Much worse. All right. So we got a rocket. Can you see? Yeah, that's good. That's pretty good. And then we got our second part. We're just testing, make sure it's not gluey, sticky. All right, that's good. Because we don't want it to glue to the airframe. Oh, we should probably take the parachute off. It's just gonna create drag. No pun intended. It's kind of their job to create drag. I might do a KSP live stream tomorrow of Kerbal Space Program. Why not? It's fun. It blows up most of the time, and explosions are fun when they're not in real life. So, yeah, I might do that. So just look out for that. That's really good. I'm super excited. This slides through freely. That means the pirate's gonna be able to shoot it out. Super fun. That's super good. All right, we're gonna pull this through. We're gonna shove this. Oh, didn't someone text me to cut something off? Clip off the end of the cords past the knot. Thank you. I will do that after I do the test. Just testing this here. All right. Okay. So it got significantly heavier. Like, it's definitely, if we were to do center of mass, like, it's tipping this way. So, yeah, it's definitely in here. It's definitely working. I'd say we'd get a success on our first Pirish fire. It's looking good. Like, look, it's sliding freely. Like, even this little shimmy. Wow, that's really, I'm really shocked. I thought this was gonna be a train wreck. Live stream magic. Anyway, so yeah, that's just an injection system. What we have next to do is my TVC. Here it is. For you, those that haven't seen it, here it is. So this is the y-axis. This is the x-axis. This will be mounted with a motor, of course, to see how far it sticks out. This will be mounted. Let's see. Yes, so this is the bottom of the rocket. This will be mounted right around here, and we'll have holes sticking out because these servo motors. We're just gonna show you how this works. When they move it, they stick out like. So this will have to, it'll like stick out of the rocket. So it moves freely. Here we go. We're gonna move this way, then we're gonna move that way. Yeah. For those who don't know what TVC is, thrust vector control, which is when you have a rocket, it's at a angle. And so you have a planned course trajectory. This is an advanced TVC, but let's say on Atlas 5 or Falcon 9, they have the Falcon 9, for example, has nylon, Raptor engines that are vectored. The most liquid rocket engines are on a vector, or vectoring mount. So this is center mass right here. So it's at a trajectory. It's supposed to go up. Like, that's a normal rocket trajectory. But it starts to have some shimmy, or a shimmy that it's just when the rocket shakes due to drag or max Q. Normally around max Q, that's when a rocket will blow up, maximum aerodynamic pressure. And so it's losing its trajectory. Thrust vectoring will, the gyroscope will say you're off course. This is not planned. Thrust vector 5 degrees to the right, or they wouldn't use right, left, or side to side. They use more pitch, yaw, roll. And it's going to tell it to correct the servo. So it's going this way. It's going to shoot it this way to correct the angle of it. So that's the beauty of thrust vector control and how complicated it is to make that. So that's what this is gonna do. I have my flight computer. It's gonna sit right around here. I'll cut out some holes here just so I can flip on switch and like manually control some things. But that's gonna sit right here. Actually, hold up. I am gonna go grab those pieces really quickly. I left them in the other room. So I'm gonna go grab those and be right back, okay? All right, so I'm gonna put the rocket aside. That's a really big win. I'm super excited. Hope that was educational. I don't think it was. We're gonna pull out some pieces. So this is brains of the rocket. So we have our teensy. These are parts. I'm just gonna give you a big shout out. Um, really helped me. He helped me kind of design the PCB board, which is the Omega board, which was really helpful. And without him, I don't think I could get this far. So here are all the parts that this kind of field that we've been working on together with. Um, so here are my sensors right here. I'm gonna move this to the side. So our sensors here are so here is I'm gonna open it for you. It's an MPU 6050. It's not the best. So gyroscope is definitely a standard. A lot of people on the BPS based Patreon server are suggesting I should get a different type of the BM the BMU the BMI 088, which is just a better it's a better gyroscope. I would have to find a place on the PCB board to solder that on because it's not a breakout, which this is called a breakout when it's on this panel. It's a piece that sticks manually to the board, so that'd be advanced kind of stuff. Definitely a 2.0 PCB board, but um yeah, so that's my gyroscope. So that will tell the TBC what to do. That's going to tell what's determine what's up and down. Blah blah blah. Here's my TNC. Here's Arduino. Here's my BMP 388. I have some pieces here and a breadboard, etc. And so yeah, that's gonna be in a future video. I'm gonna wrap it up now. Thank you very much for joining. Thank you for watching. I'll see you in the next video or next live stream, definitely this week. All right, thank you guys for joining. Hope you've have a nice night. All right, bye bye.